So my colleague Massimo introduced you different GPU systems, big and small clusters we have with a range of devices, and we have a large number of users with diverse needs. So at CSCS, of course, we want to accomplish two things. First, we want to make sure our users can do their task productively and efficiently. So we have to provide interfaces to users, of course, through Slurm, and in some cases through the Cray environment Alps, where users can ask for a specific configuration. So, and then can use tools that are available on GPUs. But most importantly, we want to have a robust operation, meaning that we want to be able to detect problems or especially faults that happen on the GPU much earlier on, because there are a number of different things that can go wrong on a system, and they can go undetected. Usually, in some cases, they are only detected by a user reporting, okay, my job is failing over and over again, and what can I do? So in my talk, I will present a few examples. I'll share some experiences, things that we have accomplished and things we have yet to do. So feel free to stop me at any point, because there are a lot of concepts, and as I jumped in the middle, you will find some repetition from what you heard in Massimo's talk. So do stop. So once you deploy a GPU in your cluster, it comes with several tools. Some tools you have to install separately. But from a high-level point of view, I classify in two categories. The first thing is I call programming tools. And these tools have to be available on your system, because if they don't, your user will yell and scream. So, of course, as a programming tool, you need a debugger. You need something to check memory for users. You need profiler and a visual variant of the profiler. But increasingly, as we have more GPUs in the system, we would really like to have some tools to monitor what is going on in regular 24/7 operation. And for those, there is something called Nvidia Management Library. It's been introduced for a while, but lately there has been a lot of development. And the discussion we just happened a short while ago, it is around these Nvidia Management Library, the APIs in there. And then there is a tool, it's a separate tool. So once you go to Nvidia website, and this combined tool chain is called Tesla Deployment Kit, you will find this tool in there. It's called Nvidia Health Monitor. So typically, if you are a user or a code developer, you would really like to use tools to run your codes efficiently, and you will more or less use blue boxes and maybe part of the green boxes just to check the configuration or query the configuration. But if you are on a sys administration side where you have to ensure 24/7 robust operation, you would find yourself using or relying more on the monitoring and management tools. So I will go through this quickly, but typically you can think about if you're a user or a code developer, you are mainly concerned about correctness of your code, efficiency of your code, because your end goal is to solve your problem as quickly as possible. While you are mainly concerned about your code, you can at the same time want to find out how your resource is configured, and if you can change its configuration. So at resource, I use green just to give you an idea. In this case, is not the CPU, is GPU, as far as this presentation goes. So very quickly, since this is not a programming type of talk, I will go through very quickly. These are the tools you have. So you have your debugger, and then we have in CSCS, we have a parallel debugger through a linear DDT. You have memcheck and rangecheck to find memory issues. You have the profiler. Not only you can get a very coarse-grained high-level profile, but you can use check matrix and events. And then you have a visual profiler, which looks like that. So I'm not going to go into any detail, but if you really, really want to know more, you can talk to me, or the person who gave the GPU intro talk can talk to you more about it. But the idea for presenting it here is, if you are a system administrator or an engineer, if one of these things are broken or don't function properly, people will be unhappy. And we had to do, especially on Cray system, for some of tools, we need to invest some time and effort to get everything working as expected. Now we move to the main part of the talk, which is how we administer or manage a system with GPU efficiently. So there are, as a system administrator, you can have many, many concerns, but above all, you would really like to know how your resource is doing, if detects and faults are developing. If a user wants you to change configuration of the device, can you do it? Is it safe to do it? Things like that. And how do you go about doing that when you make a cluster, no matter if it's big or small, if you make a cluster with GPU and if you install a resource management system like Slurm. So I don't have to emphasize this again, but why do we care about it and why we have been working on this thing for a couple of years? So we have recently installed a very big system, all with GPUs, which is PIS-9, which is a hybrid Cray XE30 system. But as my colleague mentioned, we have several other InfiniBand clusters with different generation of GPU devices that are really used by a wide range of users at CSCS, so we have to fulfill their requirements. So if you are interested in seeing this in person, you can talk to someone at CSCS, and we can probably take you there. So this is the main part of my talk. And this is what NVIDIA, in some sense, tried addressing once they started building these HPC generation devices, and then they realized managing these devices won't be same as managing a GPU sitting in someone's desktop where they can turn it on and off as they wish or will. They have to be managed differently. Just out of curiosity, how many of you have heard about Tesla Deployment Kit? Anyone? This Tesla Deployment Kit. Okay. I hope I would make it sound interesting enough so you go and search. There is a website though there. So it comes with two parts, and part of it is already in your runtime or driver. So first of all, it's a management library, and it has some user features, as we will see. So as a user, without having any root privileges, you can do some querying and find few things. Of course, it helps you in setting up your device in a certain way, setting up resources in a different way. For example, whether you want memory to be with ECC or not ECC, whether you want to set a power cap, etc., etc. As Massimo talked about, it will help you find. Now it can tell you if you have how much of the resource you have used, both in terms of time and resources, and it can help you with diagnostic and monitoring by writing third-party tools. nvidia-healthmon is just a executable that is packaged with it, and we will learn more about it. But it's more, as the name suggests, the idea is to help you monitor health of your GPU, you can use it mainly for your 24/7 operation and checks. A little bit more about NVML. It's primarily a C API. Some runtime are in nvidia-smi. How many of you have heard about nvidia-smi? I hope I get some show of hands. Okay, that's a big relief. So they are sort of together. Another one is more API for you to use. The highlights are, there is a lot more of in the document, in the user guide that comes. But at the high level, you can see that There are APIs that help you with device initialization and cleanup, which, as you could easily imagine, is a privileged type of option. Then several querying options are available, which I think users can do probably all of them. Then configuration commands, of course, you need privileged options. Then error handling and reporting, and there is a mix of APIs and constructs there. There is a Python binding available via PyNVML, so if you type it, you can see that's a very easy way to use it once you install NVML on the system. So this table I just copied from the user guide for Nvidia Management Library. And as you can see, I just picked up something where it shows me some commands on how to change different configuration option. And the reason I'll tell you in a minute. So first thing, and there are many tables in the document. So for me, the first thing I have to locate when I go to this document is which devices I'm interested in. In our case, of course, I'm mainly interested in K20X, which is marked by K20. The second thing is what else I'm interested in solving, fixing, or configuring on my system on behalf of users. In this case, I'm interested in setting compute modes, and in the next slide, I'll show you the use case scenarios. I may want to set application clocks because some of my user or codes will require that. And I may want to set different GPU operation modes. And we have a use case for all three of them, and there could be more. So before we go to that, just go very quickly over NVIDIA SMI. So if you are on a system with a GPU, NVIDIA GPU, all you have to do is just type NVIDIA SMI. And of course, when you are on a Cray system, you have to do AP run NVIDIA SMI, otherwise you will get an error because you don't have a GPU on your login node. And this is a summary command. And I'm not going to go through a lot of details. You can use this -Q option to get a lot more. But in this case, you can see there is nothing running on the GPU. Otherwise, you will find processes and usage here in this column. But you can see a few things. You can see which mode it's been set, how much memory, power. There is a lot more. So this gives you kind of a summary. If you haven't used it before, I would recommend at least trying it once. May help. Now this is where it gets interesting. So if you are becoming more or less a power user or a user interested in knowing the capability of your devices, you would like to find out maybe a little bit more. So what can you do? Summary options. So the one we saw on the previous slide. If you have more than one GPU, you can specify the GPU IDs, or what you can do is you can launch it in form of a loop. The more interesting bits are here, querying options. So you can find out a lot more, but then you can even display selective bits of information about the GPU. So you can do a lot more, and more or less everything you can do is in the user command. Here it gets more exciting, because once you see device modification options, you can see you can change persistent mode. There are pros and cons for it. We tried it on our big system. Then there is compute mode. On large system, NVIDIA recommends us to use this thing called exclusive process, which essentially means on a given node, only one MPI can talk to the GPU. And then there is this GOM mode. All on means you can do both compute and you can do OpenGL graphics, but it could it could hurt your energy efficiency. And then they have recently introduced this thing called application clocks. and then you can reset application clocks. One thing that is not clear from here, and some may or may not be very clear from the documentation, is some of these configuration options can just work just by issuing in command. For some other configuration options, you may have to reset the device. For others, you may have to reset the whole node. So that's what makes it a little bit tricky. If you want to enable this, how you enable it in a cluster environment where you may have thousands of nodes. So that poses a real interesting and challenging problem for us, but because we have use cases where we face with all these three options. So our first use case was when a user came to us, they say, I have an OpenCL code, but I cannot, and I would like to use more than 1 MPI per node, but I can't, I'm getting an error. And we say, oh, by the way, Nvidia have introduced this thing called MPS, which used to be called proxy, that should enable you to use that, multiple MPI per node. But of course it works for CUDA, not for OpenCL. So we said, okay, we have to solve a problem in such a way when the user starts its job on the node, it changes the mode from exclusive process to default, meaning that multiple MPIs can talk to the GPU. And when the job gets out, it changes back to the default mode, which is exclusive process. The second scenario we had, and this is something my colleague, I think Tim, is Tim here? Yeah. He was working with tuning GROMACS, and then they realized that if we sort of increase the clock speed of the GPU, efficiencies can go up by 10 to 15%, which is not something you cannot ignore. And we have, in the later version of driver, not the current version we have on the system, we have two flags we can sort of play with. First one is for a sysadministrator giving permission to a user to change application clocks, and once the user gets the permission, they can request the clock that they would like to, and on exit, of course, we go back to the default, or the user can reset the clock. So this is what we would like to do. The final use case is, now we have so many GPUs on our Cray machine or on Brick machine, and we have a very high bandwidth I/O subsystem. People would like to use visualization without moving the data in and out too much, and they would like to use OpenGL. And in this case, we can turn all on in the GPU operation mode, and you can do that. And as I said, it could be exploited by mainly visualization application with maybe some other application. But the problem here is you can enable it, but you have to reboot the node. And of course, when a user wants to do something, they want to do as they want, and they want to do it now. And we face with the situation where we have these users who say, I would like to be able to change permissions when I like and how I like it. And in some cases, it's easy, but in other cases, not. So if you are in that situation, how you could enable or how we enable these things. First thing is, we will have to allow user only through a job script to ask for a given configuration, because we would really like to return the machine in the default or Cray or Nvidia prescribed state as much as possible. So we have to enable it via job request. So you can, in Slurm, you can ask for a special string. And then we set up our resource manager so that request or that string can be parsed, and it returns the user, it returns GPU to the user in the requested configuration, and then the job executes on those resources. And the resource manager returns the node or set of nodes in the available pool in default state. So we were so far on our big machine successful in doing the very first one, which is the default mode. The others, we have done it on our smaller test system, but not on the main system. So user can add a string called constraint, which is called GPU default mode. And the GPU is given to the user, and then it's returned back into the original form. And if you are interested, we can talk about what we are working on other options. For example, the graphic GPU operation mode for visualization and application clocks. So this was about how we manage the system so that we can improve users' productivity. Now I talk about something which is more from a system administration side, utilization and monitoring. So first is about utilization and accounting. So Massimo mentioned that you can do it now through Cray interfaces, but if you have NVML properly installed, you can configure your resource manager to measure it. So this is something I copied. It's a rather technical description from the user guide, but there is, in the NVML header, there is a struct. It can return two values. So it's a % of time over past second during which one or more kernels was executing on the GPU. So that gives you GPU second or GPU time. It's not precise, it's not to the granularity of SM or anything, but it gives you some utilization. Because otherwise people tried running NVIDIA SMI in a loop and things like that, and that was kind of a big overhead. Percentage of time over the past second during which global memory was read. And this gives you GPU mem read and written. So these both are sampling values. So they have an overhead, but it's not probably as high as it could be, and then you can do some research to figure out if there is indeed a significant overhead. We haven't done anything ourselves to plug in Slurm because on the Cray machine, they did some work to interface this thing with this Cray utilization and reporting. And as Massimo showed, if you run a command, so you can get your GPU statistics. They show you maximum memory, some memory, and in this case, it's very easy to see since I ran it on a single node. So these two are, I think I ran it on 10 nodes because there is an extra 0 here. And then second, because if you run something that goes very quickly, it will be 0. And you will see, oh my God, I have not used GPU. So it's better to look at these two than this one. And this is a counter statistic, so it just doesn't tell you anything about CUDA or any such thing. So for that, you have to use other thing. This is my final topic, which is the health monitor. So NVIDIA, and this is something work in progress with us, between us and NVIDIA. And if you are interested, I think you should provide them also quite feedback because this is really, really early work. So if you read the documentation, you can feel a lot more assured than you should be. Because they say some very, very nice things. They say that, okay, if it is designed to software configuration issue, system configuration, assembly issue, a limited number of hardware issues. Then they talk about more, that in theory it can provide you troubleshooting help. I don't think I ever saw it providing anything, but let's hope. And then they say it is being designed so you can configure your cluster manager so before it can run as part of your prologue and epilogue. So before the job is scheduled to find if the node resource is healthy, and after it gets out to see if you can return it to the pool. And there are some other things. So it's quite, on paper, quite reassuring. So we say, okay, we should try it. We have a big system and see how useful it is. So we integrated it such that whenever a job exits, this little thing goes and runs there. And as I said, it's really, really early work. So this is kind of the output you can see. So it's run on a PIS giant. And you can configure it quite a bit. So in this case, there are 3 tests are skipped, because if you have more than one GPU, then it's worth running peer-to-peer, and of course multi-GPU. So in this case, we have single GPU. But it can do, okay, it can check if the driver is healthy, and I don't understand, and I'll have to ask NVIDIA, if you don't install a production driver version, for example, if you go and install the recent version of NVIDIA driver, it says, I don't like it, it's a blacklist driver. So any driver that is not stable production, it won't work and you'll get an error. I don't know how to get around it. And then it loads NVML and it can check your PCI and it can check your memory and other thing. But it is by no means a complete test. We have had at least 3 known cases, 3 different failures, where then the device was detected later on to have some issues, which was completely missed by this health monitor. It declared, oh, everything is good and well, and it wasn't. And then what you can do is depending on your device. So if you go on NVIDIA website, get the TDK, untar it, there is a config.ini file with the health monitor. And depending on which device or devices you have, you can select warning or minimum values. So I highlighted 2 here. Of course, we have K20X on our system, so I want Gen to be 2, PCI width with this, temperature warning, blah, blah, blah. And if you happen to have a latest generation of Tesla, you can, of course, change the PCI gen and other thing accordingly. So it's pretty customizable and not too difficult to use all in all. But don't have too much faith in it yet. But it's a step in the right direction. So this is my final slide. So what we have learned in past few years working on different GPU systems and working with vendors and NVIDIA. On the GPU side, as you see, there are so many configuration options that are available to you that you can use and that could benefit your application. But the question is, in a cluster environment, should we or shouldn't we? And how, if we want to allow our users to do it, how do we do it? And it's really, really non-trivial. So you have to put a lot of thought and attention to it on how you do it in a responsible way. There has been a lot of progress since when we started working on GPUs in a cluster environment till today. So the Nvidia Management Library, the health monitoring tool, and other tools and probes. But they are still work in progress. What did I do? Okay, I probably did something. And the reason we still have to do a lot of work is that people write complex programs. They access resources within the GPU in a different way. For example, CUDA MPS. Now we have an issue that is only shows in an MPS mode. So complex fault can go undetected. So you cannot rely on the tools that are available around. And what we are doing at CSCS, we have built our own regression suite and we are slowly and gradually extending it. So we can do that as we find out corner cases. Above all, and as we learned in the first CUDA or GPU intro talk, use cases are evolving. Every day we have a different case or usage model. And for HPC sites, it's important to have close collaboration between OEMs and system administration so that we continue providing feedback to NVIDIA and our OEM, because sometimes NVIDIA can come to us and say, look, we implemented such a nice feature, and then on the other side, Cray say, no, but you can't use it because we don't allow it such a way. And above all, I think we need to probably invest more time and resources in understanding and configuring or leveraging our existing resource management tools and interfaces. So with this, that's all I have, but feel free to talk to me about any questions you have relating to two, three topics I covered.